Okay, eighth graders, we are going to talk about roots and real numbers. So your objective today is to be able to evaluate expressions containing roots and to classify numbers within the real number system. So we have talked about this. We talked about it last year. Real numbers is basically every number that you guys are going to deal with as eighth graders. We've got two main categories. We've got rational numbers and irrational numbers. Now, rational number is any number basically that you can think of that is reasonable, okay? I think of any number that makes sense. So for example, obviously, we have nice numbers, we have decimals, we have fractions, we have positives, we have negatives. Those are all rational numbers. What's going to be classified under our irrational numbers are the numbers that aren't as nice, okay? So we are going to define these two categories first. So irrational numbers would be those such as pi, any number, any decimal maybe that you can't predict what's going to be coming next. So I'm just going to make this up, 2.1647132. Now you don't know what's coming next, right? Sometimes we get a decimal like that. That's irrational. And then the last type is if they're a square root that's not nice. If I put that into my calculator, it's going to give you a very long, complicated decimal. So that's an irrational number as well. Okay, so then we're going to come over to the rational numbers. Rational numbers are composed of different categories. The most basic rational number is natural numbers. Those are what you would naturally count with, like 1, 2, 3, 4, ... Then we have whole numbers. The only difference between a natural number and a whole number is 0. So we're going to add the 0 on there. Again, these are not fractions, decimals, or negatives. The next category is integers. This is where our negative comes into play. So we've got this. But notice no decimals or fractions. So the outermost ring of this rational number box here is where our fractions, our decimals, all those other numbers come into place. So I am going to just make some up here. And I'm just making them up just to show you that they include all of those positive, negative, those types of things. These also include repeating decimals. So for example, if I had 1.3 repeating, that is rational. You can predict what's coming next, okay? So that's how we classify numbers, or that's what chart we're going to use. So now we're just going to go into finding roots of fractions, and then classifying. So when you find the square root of something, you need to find what times what equals what's underneath the square root. And I don't really like how it does that. Usually they look like that. So what times what equals 49? And they have to be the same number. Okay, so for example here it's 7 times 7. So the square root of 49 equals 7. This next one, what times what gives you 36? Well, it's 6. The only catch on this one is that this negative is on the outside there, so that has to be kind of transferred forward there. Now this is the cube root. So it's asking what times what gives you 125. It's not divided by 125. So I know that if I had a negative 5 times a negative 5 times a negative 5, it would give me negative 125. So the cube root of negative 125 is negative 5. Okay, finding roots of fractions, it's not really that much different. I like to look at it like this. So if this is what it looks like, when you take the square root of it, you square root the top, you square root the bottom. So what's the square root of 1? 1. What's the square root of 4? 2. Same thing here. What's the square root of 4? What's the square root of 9? Square root of 4 is 2, square root of 9 is 3. Okay. Last step of just classifying numbers. When you classify a number, you do need to write all of the classifications of that number. So for example, 8/9 I'll start in my little table here. Is it a natural number? Nope. Is it a whole number? No. Integer? Nope. It is rational though. And it's real. It's just good to get in the habit of that. 18, so you start in the middle. It is a natural. So if it's a natural, that means it's also a whole number. If it's a whole number, it's also an integer. It's also a rational number. And it's real. So the square root of 20. Can you take the square root of 20 nicely? No. So that means that it goes over in this irrational category. So it's an irrational, but that is also a real. Next one is -12. -12 is not natural, it's not whole, it comes into that integer category. So it's an integer, and it's rational. It can be -12 degrees out, right? And real. And the last one here, not all square roots are irrational, because I can take the square root of 100 and I get 10. So 10 then would be a natural number. It would be a whole number. It would be an integer. It would be rational. And it would be real. It'd be all of them. So just work your way from the inside out and let me know if you have any questions.